right, so let's continue. Okay, so after we talk about those five basic antiderivative rules, and let's do some practice. So look at those five examples here. Um, Problem are all the same. Give you a function, ask you to figure out what the corresponding antiderivatives. Okay. So look at the first one. Fx is equal to 1 over square root of x. And, we learned that the first formula, if the original function f is x to the power n, then the antiderivative is x to the power n plus 1 over n plus 1 plus constant c, right? So you can think about it, guys, this is kind of like the reverse of the power law, okay, about the derivative. So let's look at this. 1 over square root of x, first we converted it into 1 over x to the power 1 over 2, and then x to the power of negative 1 over 2. Okay? So this is definitely what we can do here. And after that, we gonna try to figure out the corresponding antiderivative, which gonna be capital Fx is, since n here equals negative 1 over 2, we're gonna have is x to the power of negative 1 over 2 plus 1 over negative 1 over 2 plus 1, and then plus constant c. Okay. Of course, we can simplify this into x to the power 1 over 2 over 1 over 2 plus 1. And then you can simplify one more, which gives us is 2 times x to the power 1 over 2 plus constant c. Okay, so this is the first one. And again, guys, don't forget the arbitrary constant. Okay. Okay, so second is the same thing. Okay, gx is x to the power of negative 7. So the antiderivative is going to be x to the power of negative 7 plus 1 over negative 7 plus 1 plus constant, which gives us is x to the power of negative 6 over negative 6 plus a constant c. And by the way, guys, like I mentioned in the previous video, you can always check your answers. Okay, for example, if we take the derivative of x to the power of negative 6 over negative 6 plus a constant, and eventually you will see that you're going to get x to the power of negative 7. Okay, so that works. All right, so this is first one, second, and the third one. Not too much space, let's write it here. So mx is cosine of x over 2, and you might need to record what we just talked about one of those five antiderivative formulas. If you have cosine of kx, then the antiderivative is going to be 1 over k times sine of kx plus constant c. In our problem, k equals 1 over 2, so let's write it here. I use a capital letter to denote the antiderivative function. Okay, so capital Mx is going to be, since k is equal to 1 over 2 in this problem, so it's 1 over 1 over 2 times sine of 1 kx, which is plus a constant. 1 over 1 over 2 equals 2. So we have it's 2 sine of x over 2 plus c. Okay, plus c. So this is for mx. Again, guys, if you look at this, if you take the derivative of this part becomes 0. And this piece is here, you have 2, right, constant, times the derivative of this, which is cosine of x over 2, multiply the derivative of the inside, which is 1 over 2. So 2 times 1 over 2 gone. Only cosine of x over 2 left, which is exactly here. Okay, so this is problem 3. Here, let's look at this. Nx equals e to the power of negative 3x. And we're trying to figure out the antiderivative, which is, let's see, capital N of x. And remember, if you have a function e to the power of kx and asking you to figure out the antiderivative, you might need to go back to look at those as a formula. It's gonna be 1 over k times e to the power kx. In our problem here, k equals -3, so our nx is gonna be 1 over -3 times e to the power of -3x, okay, plus c. Okay. Again, if you take the derivative of this piece, you're gonna get this part. Okay, so you can always check the answer. That's a big advantage for the for solving an antiderivative problem. Last one, px equals 3 over square root of x plus sine of 2x. You can see, guys, this problem actually is a combination of the first one and the third one, right? And the third one. So let's write it out. So px, the antiderivative, is gonna be 3 is a constant, right? So it's a constant multiple. So no matter you do the derivative or you try to figure out the antiderivative, constant always you can, if it's a constant multiply one part, you can always keep the constant there. So we can always keep the constant there. And 1 over square root of x, we already have the answer, which is here. Okay, which is here. So this is what we can do. We can do, let's see, we're gonna have 3 times 2 times square root of x. Okay. And you see, guys, if I find the antiderivative, you all agree that if I only look at this part, the antiderivative piece is going to be 3 times 2 square root of x, right? Plus a constant. Okay, plus a constant. And when you find the antiderivative of the second piece, okay, which the answer going to also include another constant, right? So you have one arbitrary constant and another arbitrary constant, so it's going to be another arbitrary constant. So that's why, I'm going to write one single arbitrary constant after all of this, okay? So you don't have to write the 2. So the derivative is, the antiderivative of sine of 2x, if you mimic this part, you're going to have it's 1 over 2 times negative cosine of 2x, okay? Based on, again, one of the formulas. And then